Hi everyone, I'm Tao Yan and this is my cat, Big Orange. He's a 2-year-old ball of sunshine, playful, energetic, and very attached to people. Every morning those big brown eyes and crisp mouths are his way of protesting. Why do you get 3 fresh meals a day, while I only get one massive pile in the morning that has to last until tomorrow? But sadly, I'm always rushing to class or work, and can only feed him once in the morning. Big Orange says it's unfair, and honestly, he's got a point. So our team, Steven, Calvin, Frank, Lucas, and I set out to solve what Big Orange calls the biggest crisis of his life, his feeding schedule. When a pet approaches PetPal, a motion detection algorithm triggers the camera. The system uses YOLO-V8 to detect the animal, and an AI model to identify its breed. Next, the pet steps onto a weight sensoring platform. The system measures its body weight, calculates the appropriate food portion based on a nutrition formula, and then activates the motor to dispense the exact amount of food. After feeding, a message is automatically sent to the owner, including the pet's weight, the grams of food dispensed, and the current time. Smart, personalized, and fully autonomous.
The PetPal feeder requires a real-time pet detection module to identify the cat and dispense food accordingly. Here's a flowchart of the module. The system begins with real-time motion detection. The YOLO object detection is triggered only when movement is detected. Once motion is detected, the YOLO-V8 nano pre-trained model is activated to detect and identify objects. If a cat is identified, the signal is sent to the Arduino board. To achieve this, we use the YOLO-V8 pre-trained model to detect and recognize cats. Specifically, we apply the YOLO-V8 Nano, a lightweight CNN network with approximately 3.2 million parameters, making it ideal for real-time cat detection. To save processing power, we use OpenCV's background subtraction algorithm to detect motion in real time. YOLO object detection is triggered only when movement is detected.
This is the cat sound detection module. This is the data for cat sound, and this is the data for non-cat sound. And by using those data, I trained a CNN AI model right here. And before the audio go through the AI model, I run a moving average filter and the bandpass filter, which can filter out the high noise and the low frequency noise. And those are random sound which I will going to test this module.
Got a few here I'd like to show you.
Right here, it's clearly to see the AI model is it can determine whether it is cat or not cat.
Hi, I'm going to introduce my module in Capstone called Cat Breed Detection. This module aims to identify which cat is in front of the feeder. Due to we have an Orange Tabby cat, I focus on 2 breeds, the Orange Tabby and Tuxedo. I collect both cats' image from network and separate them into 2 folders called Train and Validation. I trained a convolution neural network model using PyTorch framework. In the real world, the pet's image can be blurred. I also developed an algorithm. I use Fourier transform to convert the image into the waves of different frequency and apply Wiener filter. After deblurring it, the restored image will pass into the CNN model and make the prediction. An image of Orange Tabby cat. The Pi connects to the camera module, which captures the photo, processing it using an AI model, and output the probability that the cat belongs to Orange Tabby breed.
Now let's dive into the part I was responsible for, the weight sensor and feeding module. Here's the problem. Big Orange is not exactly patient. The moment he sees food, he gets overly excited, tail waggling, paws stomping, maybe even trying to accidentally adding pressure for a bigger meal. So how can we get an accurate reading? We built our own low cell module using a Wheatstone bridge and the HX711 ADC, but the raw weight data was unstable, full of jitter and spikes due to movement and vibration. To fix that, we added 2 filtering techniques. The first one is median filter. It takes 20 values, sorts them, and picks the middle one. That removes sudden outliers, like jumping pounds. Second one is exponential moving average. It smooths the trend over time, making it easier to read. But that's still not enough. So we added a stability check using standard deviation. Only when the last 20 values are stable, meaning Big Orange is standing still, do we accept the weight as valid. Once we get a stable weight, we calculate the food amount based on a nutrition formula and activate the stepper motor to deliver just the right portion. No more sneaky tricks, no extra treats.
The analyze module will receive data through Wi-Fi from the Arduino board. The message will contain the result of cat identified part, the weight, and the time we released the food. The Python script receives the data, stores in SQLite database, and then use a Bayesian algorithm to estimate weight changes. We also use TensorFlow to run a neural network that predicts the cat's next feeding time based on the history data. By doing so, we can start from predicting with a small amount of data and keep updating the module. The system then generates a weight train graph to visualize changes over time. All this information, current weights, predict feeding time, and graph is sent to the owner's phone via Telegram bot. The user can receive the message remotely when they are not at home. So I'll show you when I run the code. Here, I receive the required information.
To conclude our video, let's take a look at how PetPal works in action. First, we use 3 AI modules to recognize the presence and identify of the cat. The object detection module confirms whether an approaching animal is a cat and sends a signal to the Arduino. Then, the breed recognition module identifies the specific type, in our case Orange Tabby, and sends both confirmation and breed data. Finally, the meow detection module analyzes audio to verify the sound is indeed a cat meowing. Once the Arduino receives all 3 confirmations, it initiates the weight measurement process. Here we use a low cell and HX711 module, enhanced with median filtering, exponential moving average, and standard deviation checking to ensure stable and reliable readings. Based on the cat's weight, PetPal calculates a healthy meal portion using a nutrition formula adapted from veterinary guidelines. After food is dispensed, PetPal sends a detailed Telegram message to the owner, logging the feeding time, breed, and food amount for a record, keeping and monitoring. On screen, you can also see the serial monitor showing our filters in real time, keeping data clean and meaningful. And finally, using TensorFlow's neural network, the system continuously learns and sends predictive insights directly to the owner's mobile phone, making PetPal not just a feeder, but an intelligent pet care companion.